And it heals itself. It's like a self-healing concrete. They're actually just being turned into biochar.
That doesn't sound good. Hot on the left, cold on the right. Crap doesn't run uphill. Payday's Friday. Bosses,
There's a 30-foot Oculus, which is like the opening.
I didn't know they had VR.
Yeah, Roman concrete.
Because the Roman Empire is cool, and we're guys, and that's what we do.
And we do think about the Roman Empire.
True facts. My wife did ask me that question. Did Christy ask you?
Yes, and my answer was like, I don't know, multiple times a day.
Starting to need some help with the reading stuff lately. I don't know if it's staring at a screen that has just ruined me, but I was the other day. I'm like looking at my monitor. I'm like editing a video, and I'm like, what's that button say over there? And so I've had to succumb to the fact that I'm in the reading glasses phase of my life now.
I'm curious about these. Like, where did these come from? Are these
are prescription?
You went to the eye doctor. Or are these like Warby Parkers?
Yes. Not sponsored. But yeah.
So you have a prescription from a doctor?
I do. I just suck at wearing my glasses.
And how old is said prescription?
This is probably like 4 years old, something like that.
So you have no idea how bad your eyes actually are. You just begun to wear the glasses that were prescribed to you 4 years ago.
Yeah, it's not good. It's not good. And I feel it's gotten worse. So this is probably not the proper prescription for me. It isn't.
Do you understand eye strain and all of the things that why we wear glasses when the doctor gives us glasses?
No, tell me, Benjamin Franklin, why don't you please give me the bifocals lesson?
See, you get all snarky and snide on me.
Oh yeah.
Oh, okay.
I'm gonna be unreasonable.
Hey, listen, we don't even know if that's aired yet. I mean,
foreshadowing.
That may not have aired.
No, it's
if
not
it has, you'll know what we're talking about. If not, it could be coming. You don't know.
It might be this Friday. I don't know.
Okay.
Production knows, all right? The team knows.
The team knows. I'm glad. But I just can't help but notice how quickly you've gotten defensive in this conversation. You got a little okay.
I get a little bit defensive, man, because I'm just feeling my age. My knees are aching.
Oh.
Yeah.
Yeah.
Like I stand up, I change Hank's diaper on the floor. You know, he rolls around. And
is that hard for you, Tyler?
Standing up is very hard for me now.
Yeah.
So I don't know. Maybe it's the top heaviness of me eating way more than I should and working out not as much as I should.
So if you were to
pickleball has started to make my knees a little bit rickety.
It does,
too.
yeah. I mean, we've covered how this is creating medical issues. Did you think you would be immune?
Well, speaking of reinforcing and structural things,
there's no reinforcement in this concrete today. there is none. Just, first point of order, there is no reinforcing, which is one of the amazing things about it.
Okay, so Lee. Wonderful Lee. Researcher Lee. Help us put all of this stuff together because this is fascinating. Talking about concrete today, y'all.
Yeah.
But not just any concrete. What kind of concrete is it?
Roman concrete.
Because the Roman Empire is cool. And we're guys. And that's what we do.
And we do think about the Roman Empire.
True facts. My wife did ask me that question. Did Christy ask you?
Yes, and my answer was like, I don't know, multiple times a day.
Mine was like, I don't know, once a week, something like that. Sam's like, why? I'm like, I don't know, like aqueducts and roads and stuff. It's what I do, all right? Like, I just need to know about these things. It's cool, all right?
My answer, I'm going to Jesus juke you a little bit here.
Why you got to do that, man?
Well, I mean, my answer was literally like, I read Romans this morning and... yeah, so...
Thanks, Pastor Eddie. Okay, moving on.
I'm just saying,
Elder Eddie. Sorry, Elder Eddie.
Yeah, Elder Eddie. Sounds like Eldorado.
Eldorado.
Kind of weird.
He is a church elder after all.
Rome,
yeah, loosely. How's that going, by the way?
So far, I haven't screwed it up.
They haven't fired you yet.
Yeah. I'm not really getting paid anything, but... That's good. I didn't take a volunteer position because I couldn't actually get paid to do the thing.
Anyway, Roman concrete.
Roman concrete.
Let's actually dig into this now.
Roman concrete is something of a modern marvel because we have it still, and it's thousands of years old. And by all rights, the Roman concrete should have cracked and crumbled and fallen a whole lot more. Take, for instance, the Pantheon. Okay. So depending on your definition of in use, the Pantheon is like the oldest in use building. And so some cool little fun facts on that. Has a dome in it that's 142 feet across. There's a 30-foot oculus, which is like the opening.
I didn't know they had VR.
Yeah. Maybe VR took that from the Pantheon. And it's still the largest unreinforced concrete dome in the world. Mm-hmm. Unreinforced. No rebar. So how do they do it?
Oh, I didn't know that. Okay.
There's no reinforcing in Roman concrete.
Interesting. Okay. And so, yeah, Pantheon. What other things, like, are we thinking like, the place where the gladiators went in and killed each other?
The Colosseum?
That's the one.
Yeah.
That's the one. What about, what I'm thinking of the Parthenon? Is that another one? Or am I thinking of the Pantheon still?
I think you may be thinking of the Pantheon. And this,
wasn't there a Parthenon?
There's a Parthenon.
There is a Parthenon?
Yeah.
Okay.
I am going to say that you haven't studied for this episode. We need to move on from Tyler trying to name random Roman buildings that may or may not be
I
Roman
haven't studied for this episode.
all.
I'm playing the idiot in the room. Okay. I have no idea what we're talking about. So, all right.
So what's really interesting is that from the standpoint of durability, Roman concrete has stood the test of time. It's still around. And there was a lot of guessing and kind of wondering about this for a long time. Like, why? Why does it last so long? Mm-hmm. You remember what Dad taught us back in the day about the 3 properties of concrete?
I actually don't
really
think I do.
Do you remember how to be a plumber?
Yes.
Okay. So
hot on the left, cold on the right. Crap doesn't run uphill. Payday's Friday. Bosses. Anyway, that's the one.
What did he told, it was son of a booger eating hippopotamus or something like that is the way he taught it to my son, which I was appreciative of. Yeah, that's the plumber one. The concrete one is it's gray, it's hard, and it cracks. The 3 properties of concrete.
I do remember that.
Okay.
I do remember that.
So the fun part about Roman concrete is that the cracking part, maybe even the gray part, isn't so much true. The concrete seemed to almost like mend itself. And they found that it would appear that lime class, like there's basically lime that when it interacts with water, like these lime class was basically like a piece of lime that's like left in a chunk in the concrete. When the water hit it, it allowed that lime to like run into a crack before that crack could get water in it and then continue to, basically be cracked more.
Yeah.
It's also interesting, like there are some caveats to this, and cite Lee for his great research here. We could arguably create concrete that was like this durable now. Like it's not like we don't have the science to figure this kind of thing out.
Yeah.
Also, like when we look at creating structures, there's always this budgetary side of things. So we should remember the fact that money comes into play. And there are some modern structures that we build to last for a long, long time. Skyscrapers and like very large structures that are at high risk for loss of life.
Yeah.
Dams would be another one. Megatunnels would be another one. Like
Yeah.
when we create these, then it's not like we're pouring the same kind of concrete that we're just throwing into a residential footing.
Yeah.
It's a different deal.
Yeah.
So we have the tech to look at this and analyze it and really create a very enduring concrete solution. So this is not to say that Roman concrete is like the lost recipe that would fix all of construction or anything like that.
No. This is something that we can do. It's just crazy expensive to do.
It's very expensive, right?
Yeah.
It's very expensive, and we do it sometimes. Like we do, maybe not in this recipe, but we do pour a more expensive concrete when it matters most, we'll say.
Right. Yeah.
Another thing is when you think about Italy and where it's at in the world and its climate, that you don't get as much freeze thaw. Mm-hmm. And so when you're in a northern climate, you get a lot more freeze thaw. And as a result of that freeze thaw wears on concrete.
Yeah.
If you don't believe it, then go up north, drive down the road and observe the potholes.
Right. Yeah.
If you're up north, that's like the bane of your existence is how bad the potholes become, the freeze thaw cycles, the salt, the different things that interact. Those aren't there on this concrete in Rome. So those are the kind of like caveats to this, like we need to consider this, that it's not some miraculous lost recipe that if we could only,
harness it again,
find it like Atlantis, that, we would be able to build some infinitely tall structure. But it is very cool because they had it figured out thousands of years ago. And pretty amazing because the things that they built out of it are still standing and around today.
Yeah.
And that seems to be the magic behind it, is these lime clasts, that these lime clasts are there in the concrete and have the ability to fill up the cracks and crevices that form. And it heals itself. It's like a self-healing concrete.
So I'm thinking of the pillars, like you've got these massive pillars in a lot of Roman architecture, right? Are those made out of Roman concrete, or are those going to be carved by like marble or something like that?
I would say I don't know, and it would depend. I don't know. I really don't know the answer to that.
Yeah,
I know when you're looking at the concrete that they are using, their concrete and ours are not too different in that concrete is very good under compression. Mm-hmm. Right. But tension, not so much.
Yeah.
Right. So that's why we mix steel and concrete today. Concrete's great in compression. Steel is better in tension. So we mix the two, we put the reinforcing in, you get the best of both worlds. They didn't have that tension side of things figured out. Or at least they weren't really applying it in what they poured. What they knew though is that if they built in certain ways, they could keep concrete in compression, right? Yeah. So they built in a way that the design worked for them. The design worked for the material. So your arches and your domes and different things like this, these things stay in compression, which gave the concrete a better chance at working to begin with.
Yeah.
So I don't know on the columns and things like that.
Yeah. I just know that that's just a massive feature of their architecture.
I'm going to say that I believe that all of that is carved because of some of the detail that you see at the top.
Yeah.
But I can't say that definitively because Lee didn't tell me. So, nor did you warn me about this question.
Dang it, Lee, in the 3 pages that you gave us.
They were pretty awesome, actually. So that's kind of the long and short of Roman concrete, is that it's almost like a self-healing concrete, and that its durability kind of pays homage to the fact that they built well with the material at hand. They kind of use the material in a good application.
Yeah.
And I would imagine where they didn't use the material in a good application, well, those things aren't really standing around anymore, right? Which is a common historical bias, is that the things that are still around are a lot of times the things that were built best. You know, the bad axes and different things, kind of like Roy Underhill said.
Yeah.
You know, they're doing the renovation and they find all these axe heads at the bottom of a well. And it's like, well, those might have been the bad axe heads that you found.
Yeah.
So, little historical bias, but we have these artifacts of history, and it's just really cool. But it brings us over into a modern day thing that we're doing, which is pretty amazing.
Okay.
Caffeinated concrete. Cheers.
Cheers. Caffeinated concrete.
So
Coffee concrete, I'm there for that.
yeah,
Can you drink it?
coffee grounds being used in concrete, and I would not drink it, nor would I chew on them because they're actually just being turned into biochar. So,
Ooh, that doesn't sound good.
Roman, you're burning it into an ash, basically, right?
Yeah.
So concrete has fly ash in it, and we're kind of replacing one of the components of concrete with biochar coffee grounds. And coffee grounds are actually a problem. 75,000 tons of coffee was being produced in Australia each year, which led these researchers done by the Royal Melbourne Institute of Technology in September 23 to see if perhaps we could repurpose it. And so in this postdoctoral student study, they tried to use coffee waste for the good of building. Like, well, we could do something with it, maybe throw it in. Obviously, there's some processing involved, but they created biochar out of coffee grounds and then put that in as an extra ingredient, and it made coffee concrete. Coffcrete.
Coffcrete.
Yeah.
Trademark. TM.
Exactly.
We're starting the company.
We're starting Coffcrete.
Coffcrete.
Yes.
A Construction Brothers
Coffcrete product. Yes. It's going wild.
Here we are with our Coffcrete today in our mugs.
So basically the process is you use the grounds and they get roasted again. So
yeah.
I would imagine this would come with the sidebar benefit of having a nice pleasant aroma and making you want to drink more coffee while you're pouring.
Which they enhances productivity.
Exactly.
Yeah. If it makes you want to drink more coffee, you drink more coffee. Therefore, you have the buzzies, which means you get more done.
Yeah.
That's the way that works.
I would say, and probably you get injured more because when you're running around like that, not good things can happen. So they tried unroasted grounds.
Okay.
They tried to take the grounds and just throw them in. Didn't really see the benefit out of that. The grounds actually weakened the concrete.
Okay.
So this isn't just like go grab a bag of concrete or a bag of concrete and a bag of coffee and throw them together and you're good.
Yeah.
What they had to do was they actually had to heat it up to temperature somewhere between 662 and 932 degrees Fahrenheit.
Woo, okay.
Quite hot.
Just a little bit. Yeah, don't drink that.
I'm trying to read this process. This is a process called pyrolysis. Pyro. I got the pyro part. That means fire. Pyrolysis. We'll Google that and ask what you actually say later. But that produces the biochar that's being used. And the biochar, that's got the benefit of it's got some porosity and permeability that enable it to kind of feed into the durability of the concrete. So it increases the concrete's adhesion.
Okay.
So when everything's coming together, the coffee traps some moisture and basically creates a hydration reaction that's responsible for allowing the concrete to set up gradually. use up the water in the mixture, and then the coffee biochar releases moisture like back into the surrounding concrete. Thereby, let me flip pages here because I am reading verbatim, allowing the reactions to continue, preventing the concrete from like drying out and cracking, because that the drying out leads to spalling cracking. So
we recreated Roman concrete.
There's a relationship.
There's a relationship to them, but we recreated Roman concrete with coffee.
Not really, because the Roman concrete, the lime class would kind of almost sacrifice themselves and bleed out into the cracks and self-heal. This isn't as much self-healing as it is allowing the moisture to hang out a little longer and allowing the cure to happen more effectively. So the greatest increase in strength was about 30%. And that was when 15% of the sand in the concrete was replaced with this coffee biochar. So fun facts to you. And that biochar was produced at 662 degrees Fahrenheit.
Jeez Louise.
Which is
it seems like hot. Quite the process to put this together.
Yeah, sure.
It's interesting that it was made, but at a mass scale, like where are you getting your coffee grounds from?
There's 75,000 tons available in Australia alone, which led to the research.
Okay, 75,000 tons. All right, cool. But where did it come from? Is that how much coffee that the Aussies consumed?
Yes, this is the cast off grounds, which is like if you go into a coffee shop.
Well, yeah.
There's a place to like send your grounds back, and then they'll try to keep them out of the landfill, basically.
Okay. Yeah.
And that's what they're doing. They're trying to take coffee grounds that are already readily available and then keep them out of the landfill and use them.
Got it. Okay.
And this is like the investigation of all this is still underway. So this is just like kind of an interesting point. You got caffeinated concrete. It's kind of fun. And it's an interesting kind of dive into mix design. Mm-hmm. Because we've got, there are super plasticizers and different things that help you with keeping water content out of concrete, right? So remember back in the day, the concrete truck comes in and there's always this war. If you keep the concrete thick, right, you don't pour a bunch of water in there, it's very hard to work with.
Right.
But it cures and it will actually have more strength.
Yeah.
Okay. If you, on the other side, add more water, it's much more workable, but you don't get as much strength out of it. Mm-hmm. So that's why we measure the slump of concrete when it's being poured. It's important to have enough water, but not too much water, because too much water will actually sacrifice some of the strength of the concrete.
Yeah.
Enter these super plasticizers. Super P, as you might have heard it called, is a means by which we can add a substance to make it more workable for a time.
It's called Super P.
It's called Super P.
I'm so sorry, ladies and gentlemen.
Super plasticizer.
This makes me giggle. Anyway.
So when you add that, it gives you a workability that you wouldn't have had for a time, right? But then there's a chemical reaction going on, and you better be ready for that junk to go ahead and harden up. When it's done, that chemical reaction's taking place, it's going to kick back, harden up, and not be workable. So it gives you a window to work in.
Yeah. Well, it gives you more control. Yeah.
Yeah. So moisture content, huge part of concrete construction, huge consideration. That's essentially kind of what these coffee grounds are doing.
Yeah.
All right. So lessons learned, what are lessons that we can learn from these different kinds of concrete, Roman concrete and the caffeinated concrete.
Yum.
From the Roman concrete, one of the things that I think is a huge takeaway is that knowing the material that you were building with and figuring that into design has a huge impact.
Right.
I think a lot of times we start we start with a concept of maybe how we want to live in something. And that's not wrong. I mean, that's the inception of most projects. I have a doctor's office, needs patient rooms and offices and different things. Mm-hmm. I have a theater. I have a concert hall. I have a stadium. Like, the use case for this is going to drive most of the design.
Yeah.
We also need to consider what we're building with. And so back to maybe a lot of the modular kitting conversations, maybe new material conversations, like how are we going to introduce a new material? A lot of times design has to consider a new material being used in order to work. Mm-hmm. Like, maybe you can get a 12-foot span done, but you can't get 13. Well, then you kind of have to respect that in design. Maybe you've got a material, like we've looked at the pull-treated members, FRP.
Yeah, fiber reinforced polymer.
Fiber reinforced polymer is a really cool product.
Yep.
It's very, like, it's got great strength that would rival steel. Mm-hmm. It's lighter than steel, but it's also very bouncy.
Yep.
It's a deflection-based design, right? So I could design some really cool things out of that, but I have to know I'm dealing with deflection, so I have to know how to use it. So I might be able to design a structure that's very light and very resilient to weather, that I don't have to galvanize and that I can bolt together and that I can basically fabricate with drills and like very normal tools, almost like I'm a carpenter.
Yeah.
But I also need to consider the fact that it's very bouncy. And so when I'm designing, I design with the material in mind, and maybe I make my base sizes work to the material. That's why a lot of materials like that are design build. Mm. Okay, so in order to integrate a material that is innovative, you need to think about how you're going to design to pull that innovation in at the front.
Yeah.
Duh.
Yeah.
Okay. I think that the Romans did this well in that they had a concrete that was available. They had, volcanic ash, they had seawater, they had sand, they had the aggregate, like they had the cement. The stuff was there, so they used it, and they built in a way that it worked well with.
Yeah.
All right. So another thing is that this whole financial side of things, like we talk about quality and, we talk about trying to design things that last. Know what you're designing, right? When I designed and built the shed in my backyard, I kind of had a shelf life on that thing.
Yeah.
I kind of do. Our homes, we to a certain degree, we build them with the understanding that, this might not be standing in 400 years.
Yeah.
But to build to a standard that would be standing in 400 years might make it cost prohibitive and might create a new problem for the housing market.
Well, I mean, that's kind of the case. That's kind of the case around here, since we're in the South.
Yeah.
You walk around downtown here in Milledgeville. What are the houses that are still standing? It's the ones that were crazy, crazy expensive.
Yeah.
That they used really good materials on. They're really bougie, and they're still standing today.
A lot of them are standing too because people have come in over the years and restored them with new materials again and again.
Yeah.
I opened some of the walls in those jokers, and it's amazing the patchwork quilt that you're left with on a house that might have been built in 1880.
And that's the testament to architecture, I think, too. It's like, I want to preserve this architecture because this is a really cool
look.
It's a cool looking thing. And I do want to preserve it so that other people can enjoy it.
Right.
So maybe the materials have been replaced over time, but there's a case for architecture as well.
Yeah. I think the last point is just innovative thinking, right? I mean, who would have come up with the idea of, well, we've got something laying around over here. How can we put it to good use? And I think that's a great way of thinking. I have a lot of something. I have an abundance, an overabundance or a waste of this thing. What could I do with it? How could I reuse it? It's just a good mentality to have anyway, right?
It's the story of Play-Doh.
Very much so.
The story of Play-Doh, right?
Very much so.
So Play-Doh was invented to clean, what was it, wallpaper?
Yeah.
Is that it?
Something like that.
Yeah, like I think it was smoky in houses at the time or something like that. So they were trying to clean the wallpaper and didn't really sell that well, I think. And then that turned into Play-Doh. It turned into a toy.
Yeah. Yeah.
So it's changing your perspective to see a new way that something could be used.
Yeah, a new way something can be used that it has not been used before. I think also just coming up with something that is seemingly useless.
Yeah.
Like coffee grounds.
Yeah.
Like what the heck? Like they're nasty. Like coffee grounds are gross.
You don't eat your coffee grounds after you use them?
Nobody does anything with coffee grounds after they use them other than maybe throw them back in a bag if they're like a really good citizen and take them back up for recycling. And, somebody saw that and went, wow, there's a lot of waste here. How can we use it?
Yeah.
And now all of a sudden it's becoming an available material for use. Mm-hmm. Is this going to take? Are we going to be building out a caffeinated concrete? I don't know, but what's the point of the story? The point moral of the story is that you can be innovative and you can think through these problems in new ways. So don't turn the creativity off. Look around, see what's there. So that's kind of what I got here for the lessons learned. Thought it was I don't know, it's just a cool thing. I mean, Roman concrete that's still around and can self-heal, and then caffeinated concrete that's using coffee. It was just fun, right?
I mean, it's coffee.
That's building fun.
We're here for that.
We're here for the coffee.
It's coffee.
Yes. So cheers.
To you, coffee.
Build something that lasts, and I don't know, thereby go build something awesome. That's what I got, man.